So the last type of polar curve that we're going to study is called the Lima Zone. The Lima Zone is the most detailed polar curve that we're going to be graphing. In order to study the Lima Zone, you're going to want to open Desmos on your browser. We're going to use that Desmos graphing calculator to graph some Lima Zones. So the Lima Zone's general form is either r equals a plus b cosine theta or r equals a plus b sine theta. A and b are real numbers. The Lima Zone breaks down into, we could say, 4 different shapes. Now, it's all still the same curve, but they just look a tiny bit different. So here are the 4 shapes that the Lima Zone will break down to. Now, they are based on the relationship between A and B. So, the first, a Lima Zone will have an inner loop if the absolute value of A, which is the constant, is less than the absolute value of B, which is the coefficient on cosine or sine. Now, I drew an example of what an inner loop would look like. So right now, to take from the inner loop diagram is just, how is this different than the other 3? The second is the cardioid, or also called the heart, because it resembles a heart, except the fact that it doesn't come to a point right here. A Lima Zone will be a cardioid if the absolute value of A equals the absolute value of B. The Lima Zone will appear dimpled when the absolute value of A is greater than the absolute value of B, but less than the absolute value of 2B. So notice the difference between the dimpled and the heart. The heart is pinched there, the dimpled looks like a dimple. And the last, your Lima Zone will be convex when the absolute value of A is greater than or equal to the absolute value of 2B. Convex, think of a lens. It's got convex. It looks very similar to being a circle, but it's not a circle. Okay? Your circle would be if A was 0. Okay? So, what we're going to start with, make sure you have Desmos ready to go. We're going to start with studying the inner loop. So what you're going to be responsible for is making a quick sketch of the inner loop. Not just the inner loop, sorry. I should say the Lima Zone that has an inner loop. You're going to be responsible for telling me the length of the inner loop, which would be right here, and for telling me the length of the entire Lima Zone, which we'll say is from this intersection here till its farthest point out from that intersection. Okay, we're going to call that the length of that Lima Zone. So what we're going to do, okay, we're going to work with Desmos, and you're going to answer some questions. So the first thing to write down, okay, you should be taking notes, writing all this in your notebook. The first thing we're going to study is, what we're going to put into Desmos is r equals 0.5 plus cosine theta. And then on the second line, r equals negative 0.5 plus cosine theta. And what I want to know is there a difference between these 2 polar curves? So, A is positive 0.5 and 1. A is negative 0.5 and 1. Other than that, there are no differences in these 2 equations. So let's get that up on Desmos. So, what we're going to want to type into Desmos is r equals 0.5 plus cosine, and now we need to grab theta. So if you go to that keypad down there, if you're on this is probably the home screen it's going to take you to, you just have to click ABC, and theta is sitting right here. So now, notice I have a pretty big axis here. It goes all the way to 60. I could see it's really tiny in here, so I'm going to want to zoom in, zoom in, zoom in, zoom in, zoom in. Okay, so there's the first one I asked you to graph. And now, on the second line, we have to do r equals negative 0.5 plus cosine theta. If you want to copy paste and then just change the 0.5 to the negative 0.5, that is perfectly fine. So notice, I'm going to get rid of it for a second. Okay, see in black. Black is telling me that's the first one. Now look, red is sitting right on top of it. So is there a difference in these two polar curves? And the answer is there is no difference at all. So let's answer this with no. Curves are the same. So A and negative A give same graph. So now let's look at what I want you to put on Desmos next. Okay, we're going to erase the two that we have, and the next two that I want you to put there, 0.7 plus cosine theta, and then 0.7 minus cosine theta. Make sure when you use Desmos, you have to make sure you do r equals. So let's check that out. Okay, so I have them listed on Desmos. So here is 0.7 plus cosine of theta. And so there's 0.7 plus cosine theta. I'm going to get rid of it. Now I'm going to click to look at minus, the one with minus cosine theta. And look, are these two the same curves? No. So let's talk about when it's the positive cosine. Think about cosine. Cosine is the x-coordinate. This is a positive cosine. Look at where your Lima Zone is opening. It's opening to the right on the x-axis. Now, let's look at when cosine is negative. Cosine, x-coordinate, right? It's opening to the left on the x-axis. So, is there a difference when b is positive and b is negative? Yes, the direction in which it opens changes. So to answer, is there a difference? Yes. When b is 1, we could say it opens to the right, or its orientation is to the right. When b is negative 1, it opens to the left. Okay, so next, we're going to look at 4 of them. And we're going to figure out what are the differences and what stays the same. So if you look at these, A is the same for all of them. And we've got a positive cosine of theta, a minus cosine of theta, a positive sine of theta, and a minus sine of theta. So put those 4 in Desmos and let's explore them. So I've got the 4 polar equations written in Desmos, and now we're going to explore them. So here's r equals 0.3 plus cosine theta. Now I want you to look at some things here. Let's examine this. So I'm just zooming in, and I want you to look at this. Okay, let's keep in mind, A is 0.3, and the absolute value of B is 1. I should really say the absolute value of A as well. Okay, the absolute value of A is 0.3, and the absolute value of B is 1. Now, we shouldn't be surprised that it opens to the right because cosine is positive. Look at the length of the inner loop. Okay, here's the length of the inner loop. if you zoom in enough, you'll be able to see that the length is 0.7. Okay, that 0.7 is coming from something. The absolute value of A is 0.3. The absolute value of B is 1. Now, let's see how long the entire length is. So this is 1, 0.1, 0.2, 0.3. The length of the entire Lima Zone is 1.3. So, let's check on the next. Okay, so we can see, looks like a mirror reflection here going on. It appears like it's basically the same exact Lima Zone, except just going in the other direction. So let's check. The inner loop has a length of 0.7. The entire Lima Zone is 1.3. They do have the same length of inner loop and length of Lima Zone. So now let's think about what we should expect to see when we do r equals 0.3 plus sine of theta before we actually sketch that. Well, sine of theta is the y-coordinate, and it's positive b, so if positive cosine went to the right, negative cosine went to the left, we should expect positive sine to be up, we should expect negative sine to be down. And let's see if they hold what was true between the other two, which is same inner loop length, same total length of Lima Zone. So let's look. Inner loop 0.7, and let's just make sure here. If this is 1.5, these are increments of 0.1, 1.2, 1.32, 1.1, 1.2, 1.3. So those characteristics are still the same. And now let's check this minus sine theta. We should really just see same thing, good, but in a different orientation. It's going down. And we could see inner loop 0.7, entire length has a value of 1.3. Now, just so that we can be clear of this, if I was to type in r equals negative 0.3 minus sine of theta, these should be the same graphs because we said that it does not matter if A is positive or negative. And look, we look at green, purple. If I take off the purple, green, same thing. So these two curves are the same. Okay, so whether A is positive A or negative A, it's going to give you the same graph. But B and negative B have a big difference. B and negative B have different orientations. So, what are the differences? What stays the same? So for the differences, positive cosine of theta opens to the right. Negative cosine theta opens to the left. Positive sine theta opens up. Negative sine theta opens down. Okay, so it's all about its orientation. Now, what stays the same? Well, we saw that the length of the inner loop and, length of inner loop and length of total shape from that intersection of the loops. So, what we need to explore right now is how do we find the length of the inner loop and how do we know the total length of its shape? So, I've got a few more for you to graph and a few questions to answer. Then, we'll be able to graph these two Lima zones. So, what I want you to put onto Desmos right now are these four. And what we're going to look at here is where is the intersection of the loops for all four? What is the length of the inner loop for each of these? Then we have to come up with what is the general length for an inner loop. Then, what is the length of the Lima Zone for each of them? And then, what is the general length of the Lima Zone? And then, once we figure all that out, we're going to be able to sketch these two Lima Zones. So, put these four on Desmos, and then we'll explore them one by one. Okay, so I've got my four equations written in Desmos. I'm going to look at them one by one. And we need to look at the length of the inner loop for each. So let's look at r equals 0.3 plus sine theta. Okay, so I zoomed out a little, but looks like I'm going to have to zoom in to gather this information. Okay, we're looking at just the first one. So let's get the length of the inner loop. The inner loop has a length of 0.7. Okay, so I would write that down in your notebook. The first one has an inner loop of 0.7. And what is its total length? Well, let's look. 0, look, the intersection is at 0, 0, and it goes up to 1.3. So the total length of the Lima Zone is 1.3, and the inner loop has a length of 0.7. So now let's go on to the second one that's sketched there. So I'm going to get rid of that one. And let's think about the orientation of the next one. Minus sine, so I'm going to zoom out a little bit because I know this is actually going to fall below the x-axis here. So let's look at it. Here it is. Oh, whoa, I'm going to have to zoom in a little. This has a small inner loop. If we look, oh, that's zoomed in a little too much. Let's zoom out. Here's 0.5, so each of these increments is 0.1. This has an inner loop of 0.2. So let's write that down. This has an inner loop length of 0.2. Notice A is 0.8. Sorry, the absolute value of A is 0.8. And the absolute value of B is 1. And it's got an inner length of 0.2. Now let's get the entire length. So from the intersection here down to here. So each of these increments are 0.1. So if this is 1.5, 1.6, 1.7, 1.8. So this has a total length of 1.8. So on to the next one. Next one, positive cosine. So we know we're going to want to zoom out a little bit. And let's start thinking about this. The first one had an inner loop length of 0.7. The second one had an inner loop length of 0.2. Think about what you believe is going to be the inner loop length of the next, and let's see if that is what actually is its length. So I think we'll be able to pick out information by looking at it like this on the screen. I don't think we have to zoom in too much. So the inner loop has a length of 3. So let's write that down. Inner loop has a length of 3. And the total length is 7. So let's move on to the last one. The last one, I think I'm going to want to move the screen this way a little bit, the grid, because negative cosine. So the absolute value of A is 1. The absolute value of B in the last one is 4. So think about what you believe the length of the inner loop is, what you believe the total length of the Lima Zone is, and now before you sketch it, let's check. Well, we're going to have to obviously sketch it. Think about it first. Sketch it after you think. Okay? So, if this is based off of the other three, what I'm thinking is I'm going to take the absolute value of A and the absolute value of B, and I'm going to do the absolute value of B minus the absolute value of A, and that's going to give me 3. I think that's going to be the inner loop. And I think when I take the absolute value of A and add it to the absolute value of B, I get the entire length. So let's see. It has an inner loop of 3, and it's got an entire length of 5, and it opens to the left. And all 4 of these are centered at 0, 0. So now make sure you write down all of your information about the 4th one. And now we have to come up with the general length of the inner loop. So for the inner loop, in general, the length of the inner loop, okay, inner loop length is going to be the absolute value of B minus the absolute value of A. The total length of the Lima Zone is the absolute value of A plus the absolute value of B, or absolute value of B plus the absolute value of A. And so I've actually done both in this area. If you look, this says what is the length of the Lima Zone. So I kind of gathered all of my data here. So we already know all of this actually goes to this bullet point and this bullet point. So this total length actually just belongs down here. Okay, so we've answered all of those questions. So now I think we are ready to graph 2 Lima Zones. So they don't have to be perfect, but you should have the right orientation. Okay, right point of intersection up. Where is intersection of loops? All of them are at 0, 0. What appears to be 0, 0. So we'll just write that. So let's get to graphing number 1. So for number 1, what we have to do in both of these is graph it, state the length of the inner loop, and the total length. So if you forgot, what the Lima Zone looks like with an inner loop, you can just graph one on Desmos. Don't graph these on Desmos before you try it on your own. So number 1, r equals 2 plus 3 cosine theta. Let's think about its orientation. It opens to the, well, it depends. It's cosine. Cosine x coordinate, either right or left. Since it's b is positive 3, it's going to open to the right. Now let's get the length of the inner loop and total length. So inner loop is going to be absolute value of B minus absolute value of A. So it's going to be 3 minus 2. So the length of the inner loop is 1. And the total length is the absolute value of A plus the absolute value of B, which is going to be 2 plus 3. So it's got a total length of 5. So if we are to draw this graph, okay, 1, 2, 3, 4, 5. That's all we're concerned with is the x-axis. We're not really concerned with the y-axis. And the best way to draw this is to start here. Okay, we'll have this come out like so. It's going to hit that 5. It's going to come back around and it's going to loop. Whoop, that's 1. It's going to hit 1 and loop like that. So, number 2, r equals 1 minus 1.3 sine theta. This is going to open down. This opens down because sine, y coordinate, b is negative, opens down. So grab the inner loop length, grab the total length, and try your best to draw the Lima Zone. Try it on your own. And mine looks a little lopsided, but that's okay. So where you start it when you're trying to draw these are at the origin. You start with the outer loop. You hit the total length, 2.3, so a little bit below -2. Come back up, get back to the origin, and then make your inner loop. Okay, try your best at making this. What's most important is that you can identify that this has an inner loop, okay, because any Lima zone in which the absolute value of A is less than the absolute value of B will have an inner loop. So that's super important to be able to pick out. And knowing what the length of the inner loop is, okay, and knowing the total length of the Lima zone. So if you can identify that the Lima zone has an inner loop, what its inner loop's length is, and its total length, you are in good shape.